Hey there, 6th grade. In this video, we're going to look at transformations. What do I mean by a transformation? A transformation is a change in the position or orientation of a figure. So, for instance, if I have a point A that I decide I want to move into a different position on my paper, from here to here, this is known as a transformation. I've taken a point and I've moved it to a different position on the paper. If I have a horizontal line and I want to redraw it as a vertical line, that's also a transformation. I've changed the orientation of the line from a horizontal to a vertical line. Whenever we transform a figure, the resulting figure is what's known as an image of the original. Images are always congruent to the original figures whenever we do one of the following transformations to them. So there are three types of transformations we're going to look at in this lesson, and each of these transformations keeps the original and the image congruent to each other. The first type of transformation is what's called a translation. In a translation, the figure slides along a straight line without turning. So, for example, if you look at the figure to the right, I have an ice skate. If I slide the ice skate to the right, that is what's known as a translation of the original skate. The figure has gone to a different position on the paper, but I haven't turned the figure whatsoever. I've just slid it across the paper. The next type of transformation is what's called a rotation. In a rotation, the figure turns around a fixed point. A very common example of a rotation that you should be familiar with is a clock. So imagine you have a clock with both a minute and a second hand. The way a clock works is the minute and the second hand rotate around a central point. They rotate clockwise in order to tell you what time it is. Okay, so that's an example of a rotation. Finally, we have what's known as a reflection. In a reflection, the figure flips across what's known as a line of reflection, creating a mirror image. So look to the right. We have a picture of another ice skate here on the left, and on the right is the image of this ice skate flipped across this imaginary line of reflection. So you can almost imagine this line of reflection as being a mirror. And if you were to hold this left ice skate up against the mirror, you would see what's on the right. So these are the three different types of transformations: translations, rotations, and reflections. And now we're going to practice identifying those transformations and then using those transformations on a coordinate plane. All right, in examples 1 and 2, you're asked to identify each type of transformation. We have some sleds here that we're going to be transforming. In number 1, the original is here, and you'll see this arrow shows that the image of the original is now up here. This sled slides from the original position down below to this new position up top. And so anytime a figure slides, that's what's called a translation. Okay, and number 2, here's the original image on the right, and then this image turns along this arrow, and now it looks like this on the left. Whenever a figure turns, that is called a rotation. Okay, let's look at the next. I want to talk about this symbol here, this symbol that looks like an A with an asterisk. This is actually read as A prime. A prime. And we use that symbol to represent a point on the image of a figure that corresponds to an original point of the original figure. So if you had the symbol A prime, that point would correspond to point A of the original figure. So we're going to use those symbols as we do some transformations on these graphs below. So in each of these graphs, we're given some instructions on how to translate an original image or how to transform an original image, and we're going to practice translating, rotating, and reflecting our images. So let's look at number 3. In number 3, I'm asked to translate triangle ABC 6 units right and 4 units down. So remember, when we're translating, we are sliding our figure. So to do this, I'm just going to slide each of the vertices on the triangle 6 units right and 4 units down. So it's going to look like this. If I take point A and I translate it 6 units right, there's 6 units right, and 4 units down, point A is going to end up here at 2, 1. And so I'm going to label this point A prime because this is now the corresponding point in my image. I'm going to do the same thing to point B. I'm going to translate it 6 units right, so 1, 2, 3, 4, 5, 6, and 4 units down, 1, 2, 3, 4. So it ends up at 2, negative 1, and I'll label that as B prime. And then I'm going to take point C, translate it 6 units right, and 4 units down. And so that ends up at 5, negative 1, and we'll label that as C prime. So this triangle I'm drawing here now in blue is the image of triangle ABC, the original figure. Okay, number 4. The instructions are to rotate triangle JKL 90 degrees counterclockwise around the vertex J. So because I'm rotating around the vertex J, that means vertex J, this point here, is going to stay put. That point is not going to move in this figure. What I need to do is I need to start by rotating line segment JK, which is this side of the triangle, and I need to rotate it 90 degrees counterclockwise. Counterclockwise is this direction, okay, the opposite of how a clock's hands move. So to rotate counterclockwise, I'm going to imagine side JK is like the minute hand of a clock, or the hour hand, whichever you want to think of, and that the point J is the center of that clock. If I wanted this hand here to move counterclockwise 90 degrees, it would move from a 6 o'clock position, which is what it looks like now, to a 3 o'clock position by rotating in this direction. So we're going to go from here to here, and I can label this point as K prime. Notice I've kept the length of the line segments the same. Segment JK was 3 units in length, and the new line segment JK prime is also 3 segments in length. And so now I'm going to draw the rest of my triangle, keeping the new sides the same length as the original sides. So that means side KL is going to become side K prime L prime, and side KL was originally 5 units long. It is now going to be 5 units along, but it's rotated. This triangle has rotated around point J. So now side KL will look like this. Instead of being a horizontal line segment, it is now a vertical line segment, and L prime is up here. And then finally, side JL, we can find that image's side by connecting points J and point L. And so now we've drawn a rotation of the original triangle. Okay, the triangle is rotated 90 degrees to this new position. Okay, finally, example 5 asks us to do a reflection. It asks us to reflect the figure, which looks like an arrow, across the y-axis. In order to reflect a figure across the y-axis, we just need to imagine that the y-axis is a mirror, and we need to think about what the reflection would be on the other side. To do that, we're going to draw our new points. We're going to keep the y-coordinates the same. The x-coordinates of the points are just going to be the opposite. So look at point A. Point A has coordinates of -5, -4. The image of point A, or A prime, will have points at 5, -4, which would be right here. Again, the y-coordinate stays the same, but the x-coordinate becomes the opposite. The same for point B. Point B has coordinates of -3, -2. It's going to have coordinates of +3, -2 on this side and become B prime. Point C, -3, -3. That will go to 3, -3 now. Point D, -1, -3, goes to 1, -3 as D prime. Point E, -1, -5, goes to 1, -5, E prime. Point F, -3, -5, goes to 3, -5. And becomes F prime. And then finally point G, -3, -6, goes to 3, -6, and becomes G prime. So now we have the following figure. It's still an arrow, but now you can see this arrow is reflected on the other side of the y-axis. Okay, you're going to practice this the next time you're in class. If there were any questions on this video, make sure those are written down for your math teacher. And until then, have a nice day. You're all wonderful people.